Good morning everyone. Currently I'm studying biomedical engineering, and in this video I'm going to construct the healthcare monitoring box for patient in the hospital. Let's go.
Yes, so before we begin, I would like to talk about the purpose of this project first. This is an IoT-based health monitoring system that allows users to track the temperature and humidity of a patient room in real time using the blynk application. However, this box provides only basic measurement, including the oxygen in blood, heart rate, room temperatures, and room humidity. Yeah, so this is my wiring diagram and drawing of the box. Sorry for my rough drawing, but we will following this plan for the project. Yep. Okay, as you can see in the wiring diagram, these are the components that we will use in this project. Okay, let's take a look at each component. So the first component is the breadboard, which is a tool used for prototyping electronic circuit without the need for soldering, and we will apply this board in our IoT project. The second component is the most important. It is the ESP32, which is the core of the system. And the ESP32 can handle sensor data processing and output display. It can also communicate with other components. Furthermore, it is programmed to send data wirelessly via Wi-Fi to connect with the blynk application. The third component is the power oximeter. This sensor can measure heart rate and SpO2 by using the infrared and red LEDs. The fourth component is the DAT11. It is a digital temperature and humidity sensor that will be used in our IoT project. It measures temperature from 0 Celsius to 50 Celsius and humidity from 20% to 90% RH. Next is the OLED display. The OLED screen can show real-time reading of heart rate, SpO2, and the temperature. So we will apply this to read the information that come from other components to show up on the screen. Okay, let me open it for you guys. Just a second. I can't open it, bro. Okay, never mind. Okay. The last one is the box that we will put the component inside to hide the wires and most of things. Okay, now we will test all of our components by combining them with the code provided by the libraries. The first component that I decided to check is the DHT11. I open up the DHT tester example and then I change the pin to 15 and set the DHT type to DHT11 according to our wiring. And now we start to run the code, and as you can see, there are the information pop up in the serial monitors. That means this component is not broken, we can use it. Okay, next we will check the power oximeters. Same as with the DHT11, I will use this library to test it. This is a picture of our wiring, then we will start to run the code. Okay, now the data is pop up now, so we will try to touch the sensors and let's observe the number that changed. And we can see that the sensor measures my heart rate and SpO2. Okay, let's check our last component. Okay, now we can see that the OLED is now connected to the data. Okay, now let's combining everything together. Okay, as I showed the picture at the beginning of the video, right now we will now follow the plan. Alright, the wiring is now complete. And next we will move on to the most exciting and fun part of the video. We call it coding.
$2,000 later.
Alright, finally we have got the code for the IoT project. So let's look into it. The first 3 lines is for the template ID, template name, and the blynk token to connect to the blynk. And this part is the include libraries for different components. Using the project, it sets up the communication with an OLED display, power oximeters, the AT11, as you can see is the pin zeros, and Wi-Fi and blynk app, they are all included and defined in this line. This section initializes the key components, including the DHT sensor for temperature and humidity, the OLED display for output, the blynk timer for scheduling tasks, and the power oximeter for heart rate and SpO2 measurement. Variables are declared to store the sensor data with the SVAS report, taking the time of the last update for periodic the report. And these 2 lines is the password for connecting the Wi-Fi. For this line, when we touch the sensor, the beat detected will pop up. In the setup function, we initialize serial communication and set up the DHT sensor and connect to ESP82 to Wi-Fi and the blynk app. This section is the code for the OLED display. If the initialization is failed, it will print an error message to the serial monitor. And after successfully initializing, it will clear the display. And I have set the text size and the colors and position also, and it will show the message initializing for 2 seconds. Next is the code for the pulse oximeter sensor. If it's failed, an error message is displayed and the program will stop. If successful, it's print a confirmation, update the OLED display, and set a callback for beat detection. Okay, now we made the while loop. This loop function is continuously runs the blynk app, update the power oximeters, and reads temperature, humidity, heart rate, and SpO2 data. This part of the code is to print the desired data. If the condition is met, the program will display the sensor reading. In this part is for connecting the data stream that we created in the blynk app. For this section is similar to the print condition, but it's specifically for the OLED display. Okay, now we will set up the blynk app to connect with our ESP32. Okay, as you can see, I have already prepared the data stream. You can see how I set it up, and I have also created the web dashboard to read the data. Yeah, finally we have finished our project. Let's see what happened after we run the code and observe the temperature and humidity from the blynk app. Okay, that's the end of the video. I hope you enjoy it and gain some insight from my project. Thanks for your attention.